Continuing on, I have another example to go. Given the two vectors, a and b are vectors with magnitude of 2. Well, if this is really how I'm picturing those, I could say that's 2, 0, that's a, and I could say that b is 0, negative 2. And if I really want, I could say c is 1, 1. I know that's 45 degrees because it's cutting this exactly at half. Doesn't look like component. There we go. If I want to find a dot b, well, a dot b, I could simply say, hey, that's 0. Why is that? They're orthogonal. And if you're not convinced, you could say take 2, 0 and dot it with 0, negative 2, and that is 0 plus 0, which is 0. No big deal. There it is. And if I said find a dot c, well, if you remember, that's the magnitude of a, magnitude of b, times the cosine of the angle between those. So a dot c, magnitude of a is actually 2. Where did b come from? Magnitude of c, well, what's the magnitude of c? If c is 1, 1, isn't this radical 2? And the cosine of 45 degrees. Wouldn't a dot c equal 2 radical 2 times 1 over radical 2 or radical 2 over 2? That would be 2 units. Kind of fun. You have a problem like that. I want you to make sure that you see it. Now we have this directional derivative that's going to help us with the comp of a vector onto the other and the projection. So the directional angles of a non-zero vector v are the angles alpha, beta, and gamma, in which I misspelled that. Okay. In interval 0 to pi, so they have to be between 0 and pi, that v makes with the positive x-axis, y-axis, and z-axis, respectively. Well, this is something we're going to be playing with. That is, when you look at this from the x direction, what do you see? When you look at this from the y direction, and when you look at this from the z direction, what do you see? So, the easiest for us to see is really looking from the y, and I'll go over that really quick. So, it turns out, if I'm looking at the y axis, if I'm looking straight at the y, what I see, this vector is right there. I see that projecting on the wall, kind of like put a flashlight on it. This angle right here is beta. And according to what I have written, A is the I, B is the J, C is the K, this right here will be B. And wouldn't this right here be magnitude of vector V? So if I really wanted to see the projection of this, well, I know that the cosine of beta equals B over the magnitude of V. And that's pretty much how I got this. So the angles here are running from the x-axis to this vector, but this vector is not on any of the, it could be on, a plane, but it's really in space. So those angles don't have to add up to anything. I have an example to explain what this means and how this works. Let me draw A, and let me draw A really big. So hopefully we can see what we're dealing with. So if I take A, and I say A is -2, 5, -3. So V is this vector. So as you see, it's running into the wall 2 units, 5 units to the right, units down. Well, let's see what alpha. I'm reserving alpha for the I component. So the cosine of alpha is -2. The magnitude of A is obviously the square root of 4 plus 25 plus 9. The magnitude of A is, what is that? 38, is that right? The cosine of beta is 5 over radical 38, and the cosine of gamma is -3 over radical 38. So alpha is, beta is, and gamma is. And remember, you have to start on the positive x-axis. I'm going to get my calculator out, and I'm going to take the inverse cosine of, where's that negative? -2 divided by square root of 38. 109 degrees, about. And if I go back and input a 5 right there, 36 degrees about, roughly. And if I go back in there and I input a -3, (119 degrees, give or take, about. So what this means, if I really wanted to start on the positive x-axis, I'm going to have to rotate all the way past quadrant 1. It doesn't look like it. Let me make it better. That's 109 degrees to line up with it. Oh, no, it didn't get erased. Right? So I'm going to go straight for it. It's really this part. But it's under. It looks like it's in quadrant 1, but you know the drill, right? That's really going to that shadow right there. That's 109 degrees. A bit hard to see. If I look at beta, so from the actual y value, all what I have to do is rotate 36 degrees, right? And I'm going to the right, right? Not to the left, to the right. And if I go for gamma, that's starting on the positive, I have to run all the way down past the floor 119 degrees. That's really what you're doing. I was going to do it in quadrant 1, but I tried an example like that and it wasn't very good. It was very confusing. So this, I thought, if you could imagine it, it looks better. And that pretty much takes care of this section.